Oh, it's going. Hey everyone. Sorry, I missed the notification. Welcome to wasmCloud Wednesday for Wednesday the 25th. Let me go ahead and show the agenda for today. So last week we had a super successful wasmCloud Innovation Day. If anybody happened to miss that or didn't catch the live stream, just a general shout out that we do have a blog that's been published on the homepage or on the wasmCloud page. Thank you so much, Eric, for writing this one up. That just goes through a full recap of what happened on wasmCloud Innovation Day, the different sessions, and it has different links or different timestamps to the various talks and deep dives that we had during the day. This is totally worth a watch, at least worth a read through on the different sessions. So I hope that you all can enjoy catching up on this if you can attend the meeting last week. And anyways, moving on to today's meeting, we've got a couple of demos and discussions. So we're going to go ahead and start with Roman giving an update on the Go component testing that he showed last 2 weeks ago with Wedge. Roman, go ahead and would you mind this project changed names recently, right? Would you mind
Yeah,
explaining what the project is and yeah, some of the changes you've been working on as you go through the demo?
yeah, absolutely. So you might remember this project called West for reusable test, but two concerns here was one that, well, West is already used for some other projects, so we wanted to, but didn't want to step on anybody's toes. Another thing is that it's really changed its purpose a little. I mean, it's as project developed at this point, what it became actually was sort of like a bridge between your native code and components. So effectively, what we call it now, lets you do is lets you access functionality exported by components in your native code, right? Like you would import a library, the same way you can effectively import a component and depend on functionality exported by that component. And it just happens so that such functionality is extremely useful for testing and, to um, in particular testing components and then, testing components as if they would be, native code running on your system using all the tooling that and love. That's like Delve, for example, for Go. So can you use debuggers and all the other tooling you already use to test, well, your components as native applications. Does that answer the question? Okay.
Yeah,
So,
yeah, sounds great. Thanks for the background, Roman. And while I'm on thing, will you mind zooming in just a little bit, depending on what
okay.
your thing is?
That,
Thank you.
okay. Good enough. Um, right. So I'm going to jump right in, and I have already talked a little bit about this project earlier. But yeah, so I'm going to just jump right into an example, which is actually available in the repository, and I'll show what was actually has been has been changed over time. So here's my very basic what HTTP implementation in Go. And here's the width for my application. So I've called my world app, and so I'm targeting what HTTP proxy world, and I just include some imports from what CLI world for all my regular kind of Go things to work. And so all this component does, it serves any request essentially, and then just prints hello world to the response body, right? So I can use TinyGo to build such components to preview to, and I can run this component with Wasm time, and so I can now curl and I get hello world, all great and very fun. Um, Now I might want to test this component, but if I try to do something like go test, just right off the bat, right, I get a bunch of errors from the compiler because, well, there are all these Wasm imports, which I'm trying to import here, but they're not present, in my for native code, right? It's something that your WebAssembly runtime will provide you at runtime, but it's not something that I can actually ever get for native application. So that's where Watch comes in. And so what I can do now is I will use the bindgen provided by the project. Like this, I'll just do go run. You might also notice that I think the last time I presented this, it was still in my private repo. So now it's moved to wasmCloud, actually the wasmCloud project now. So I can just do go generate to generate bindings for watch. And now I can actually run tests, and well, my test will work now in a second. Here we go. It does compile now, right? So what happens here is I have my HTTP test, which just asserts this behavior that we expect, right? So it just really asserts that I get hello world back. But the important thing I want to show here is the fact that I actually am using just standard library HTTP functionality for the most part. So here I do HTTP new request. So this is actually just standard library HTTP functionality to create a new HTTP request. Like there's nothing specific to WASI actually or anything WebAssembly. And so I create my new request and I set a bunch of headers here. So this is the entry point I use to call my, this function, which normally would be exported by my WebAssembly component. And I just have to pass it in as a parameter for watch HTTP handle incoming requests, right? So unfortunately, we cannot generate, there's always going to be some manual part here because you are generating bindings yourself for watch HTTP. So you have to somehow give us the function here. And so, yeah, that's the only specific thing for WASI, essentially, this one line. And then I give it in an HTTP request, a standard library HTTP request, and I get back a standard library HTTP response. This is the signature. Docs are coming soon. So I see here it's just a regular HTTP response from a regular Go HTTP library. And yeah, so then I can just assert as usual, like as I would do in any other Go application using any other HTTP library, right? I can just use standard library HTTP just for all the functionality. So similarly here, I can just read the whole body using IO package, and then I can just assert. So yeah, that's what I've been working on for the last 2 weeks, like the update of this. But the other thing I wanted to show you also is, I guess, a bit more complex, is that it was all great because, it was just out-of-the-box functionality, right? I just used white HTTP and all the WASI normal imports, but nothing extra. But some applications might have custom interfaces, right? They may have custom imports, custom functionality that they want to be able to use at runtime. So that's also supported by Wedge, and I'm going to show how it's actually done. But I'll actually show a test. It's not working. Right. So in this application, on top of what we've seen so far already, I'll use two more interfaces. One will be Fibonacci implementation. Another one would be a left pad. It'll be a streaming left pad. So it's going to take in a stream and actually two streams, and it's going to pad to the left. Let's see. So here's my left pad. Takes in a stream, another stream, a length of how long to pad, and then the character, the Unicode character, which not necessarily ASCII, right? It can be, for bytes long. So get my Fibonacci is, just takes an index and returns a Fibonacci number associated with that index, right? And so my application then is actually very similar to what we've seen already, but it will, in this case, it will expect a post. It will fail if it's not a post. It will then parse the query and the path. It will expect to get the Fibonacci number index in the path, right? Then it will take that Fibonacci index. It will call our Fibonacci function to get the Fibonacci number. And then it will left pad for that many, this Fibonacci number that I got, right? And it will use a constant character here. So first, let's see this actually working. Do go test, and let's run a test. This actually is faster in real world scenarios. Here I'm using a debug build, so it's not optimized, but in real world it would be much faster. Right, so As you can see here, I essentially it's the same thing you already seen before, right? It's just the same thing, except now I just assert a different output and I construct my request differently. But this is all, again, standard library stuff. There's nothing specific, nothing new here. And so to make this all work, I had to do this little init here. This is really just convenience, again, very standard Go procedure. So now I call watch to create a new instance. So I pass in this platform harness, we call it, which is this component which exports all the functionality, all the WASI, re-exports all the WASI functionality, basically. And so that's my one bit of configuration I have to do, which is set this global instance. I could also do it per test if I wanted to, but in this case, I just want to do it globally. And if I didn't do that, by default, Watch would just create its own instance, which would be just re-exporting all of WASI. It also has support for things like WASI key value and WASI runtime config. So essentially everything you would expect is just out of the box available to you and ready to use. So there's one little bit also to actually have to actually build a component like this, and I'll use Rust to actually build such a component. And let's take a look at the component. So inside my component, I have implemented these two functions. Here it's Fibonacci. Yes, we should be familiar with how that works. And this is my left pad, kind of streams. So it's a bit more involved than just putting a bunch of bytes in a list. But so yeah, it's just again regular WASI functionality. But the cool thing here is that I'm not actually composing any components here. I'm just just building a regular single Rust component. And so to make this all magic work, where I'm actually passing through, like I'm re-exporting effectively whole of WASI in this component. But as you can see, it's really small, right? There's nothing extra to it. It's just these two exports implemented, and that's about it. So there's WASI pass-through series of crates actually, which is also now in wasmCloud. And so what that lets you do is effectively the main entry point is just importing it. Like you can actually see it in Watch source itself. Like all we have to do is just import a crate. And so by importing these crates, we are actually setting up all the exports of WASI. Like we essentially, by simply importing this crate in your code, all the necessary machinery behind the scenes is going to set up such a way that all the WASI imports are going to be all the exports are going to be re-implemented in terms of WASI imports from the host, right? So like for example, for your let's say WASI IO stream, right? So like a read, WASI IO stream read is going to be exported from this component and it will be imported from the runtime. And in order to just compose with this thing, all I have to do is just import this crate. So then also here I just need to add these extra width specifications just to replace effectively all these WASI IO things that are already implemented by the WASI pass-through. So I just specify that here's a little extra config, and yeah, that's about it. So if I wanted to, for example, extend, let's say, this pass-through with some functionality which does not depend on WASI IO, I won't even need to do this, right? I could actually just generate bindings regularly without these specifications here and just export my function. So yeah, hopefully this tells you something new about Wedge, and maybe you'll be interested in trying this out.
Hey Roman, this is awesome. Like from this is the part that I understand right now, and I have a follow-up question around the Go component, like being able to generate native like implementations for WASI interfaces. So like when you're running the test, you're running like just Go test. Is it a local, or like are you running essentially just a Go test, or are you running a component in like a WebAssembly runtime?
No, so I'm just running regular Go tests. So I actually, last time I showed it also this test running in Delve. So I could also do it right now, but I didn't, sorry. But yeah, so it's just regular Go. It's nothing, there's no magic here, right? It's just regular Go functionality.
So cool. Okay. Now here's the part that I don't quite understand. So the last thing that you were showing, the WASI pass-through crate, um, it looked a lot like the examples that we've built like with the WASI crate where like you import a crate and then you use whip bind and you say, hey, this is already generated. Can you explain again like what the benefit is? So when you're doing like a Rust component and you import WASI pass through, does that let you test the Rust component? I guess I wasn't really clear there.
Right. Okay. So the way Watch works, first of all, right, is that it's all centered around the idea that there is a component which exports functionality, right, that you want to call. Effectively, it exports all of WASI. Like for example, WASI IO stream is exported by a component, right? So when you in your native code, when you're gonna still call like streams dot read, right? But blocking write and flush, for example, let's say that's a function you're calling, right, in your implementation. So that function actually is handled by a component running in an embedded wasm type instance, right? And so for that to happen, that components running in that wasm type instance has to export that functionality, right? It actually has to export, it actually has to implement wasm stream. And the way it does that is by effectively just proxying to the host. It imports wasm streams from the host and then exports wasm streams itself, right? So now if you wanted to, so that's great and that works out of the box, right? So now if you want to extend this pass-through, let's say you want to use wasm streams, but you also want to export, well, Fibonacci, right? So now for that use case, you would need to create a component which would both re-export all of WASI. Like you have to implement a component which would implement WASI IO streams and implement Fibonacci, right? But normally you probably don't want to re-implement WASI IO streams and WASI IO poll and WASI IO error and WASI, everything, because there are actually very many interfaces there. And so WASI pass-through crate is what allows you not to, redo all that work and just set up this pass-through, this proxying to the host by simply importing a crate. Does that answer the question?
Think so. So this doesn't like the WASI pass through crate doesn't may not necessarily affect testing. It's more around like writing the component itself or like exporting additional functionality, like Fibonacci, like something that so like when you export a custom interface, for example, that uses a stream, you can use WASI or WASI pass through, so you don't have to re-implement that stream.
Yeah. So this crate is only ever useful to build this harness that would run in runtime, and only when if you need the custom, harness. So effectively, it's low-level stuff for very advanced use cases. But I just kind of want to show it works and it also can be done and how to do that.
Okay. Yeah, I think that's going to be super helpful. We got a couple other things that I'll talk about regarding our examples, but I think that's probably going to be the best way to show this off is just by, you know, our example components, just be like, hey, look, here's this test and here's how it worked. It's cool. I'm sorry, everyone. I've been monopolizing the question time. Do folks have questions for Roman? And we'll probably time box this until until the half hour, just so that we can make sure to get the rest. Yeah, Masood, go ahead.
Hey, Roman. Great word, actually. Uh, Quick question. This works the same within the context of wasmCloud platform on the way? I mean, it doesn't interfere in any way in all of this chain that you said, right? Between the, let's say, the native environment and Wasm runtime.
Um,
Because your component is running in the Wasm time runtime. And your caller is calling on the OS, whatever, it's some other. And wasmCloud is in the way here. It doesn't do anything here? I mean,
So in this action, so right now, wasmCloud runtime isn't used at all here, right? We just use out of the box wasm time in the watch runtime. It's just really just little embedding of wasm time. So going forward, what we would want to do is, I guess, extend this this pass-through component, this harness, to re-export also some of the wasmCloud functionality. Like, for example, there is the API to, secrets, right? Or set a link name. And so these things actually are not available right now in Watch, right? So if your application uses secrets, for example, using I believe that's wasmCloud interface, right, Brooks?
Yep. Yeah. Secrets is a Wasm Cloud interface, and it's built into the host, so that would be a um good thing to do for. Oh man, I would go down a rabbit hole. That'd be fun to implement with like environment variables, like during the test. Okay. Anyways, continue.
Yeah, exactly. Yeah. Yeah, so for example, let's say wasmCloud secrets is not actually available off the box. So one way you could do that would be to use WASI pass-through crates and build your own harness components, which would, implement your own wasmCloud secrets, and then, present this component to watch runtime. Yeah, but so for now, it's just really just a WASI interfaces, key value, and the runtime config, and that's about it. Does that answer your question?
yes, thank you.
Roman, we had a question in the chat too. So Adia asked, so is the WASI pass through basically like a loophole around automatically implementing the boilerplate, like rewriting HTTP error, etc., for supporting interfaces?
In some sense, yes. In reality, I really wish it was a loophole. Unfortunately, I had to do it all by hand. Like every single function was re-exported by me manually. It was a lot of fun to implement. Yeah, but effectively, that's what it is. Yeah.
I mean, not to put this all on you, Roman, but better you do it than everybody does it individually, right?
Exactly. That's exactly the purpose of the crate. Because you do not want to do it yourself.
Well, this is super cool. I can't wait to with what's going on with with the component SDK Go and with Wedge and WASI pass through. I can't wait to update our examples that use Go to use all these Go libraries that are just going to make it well, one, work, and two, just look so much nicer. All right, folks, I'm going to go ahead and call that we should move on to the next agenda item. But thank you so much, Roman, for coming on and talking about this. I think the next thing you'll see of this project is probably our examples getting updated to use it. So as soon as we have that, we can we'll keep everybody updated in the community meeting. So for now, we actually are not moving on to discussions. You all get the very nice special of 2 demos in one day today. So Lachlan, you are going to be talking to us about a Backstage plugin.
Yeah, that's it. Yes, yes, I am. So we've been at Cosmonic. We're talking to the community members and seeing what people use in sort of enterprise organizations. And one of the projects, part of the CNC that's been gaining a lot of traction in the platform engineering space is Backstage. And if you haven't heard of it, Backstage is like I said, CNCF project. It was donated to the CNCF by Spotify because they wanted a way to. They built it because they wanted a way to surface all of the different pieces of their platform internally amongst the various teams that they have. So I'm going to share my screen a little bit here and just go to the Backstage website, just to give a little bit of an overview on it. Yes, I can do that one. Oops. Let's try again. Look at me, I'm in the corner. Hey. So one of the things that to give you a rough overview of what Backstage is, I can't do a better job than they already have. But basically the way that it works is you define the parts of your application, or many applications as part of a larger organization. Those go into a service catalog, and then you can also extend that interface with various plugins that add extra information about the services and pieces of the application that you can build that are available through the platform. So I'm trying to find the one that was good, but doesn't. The one that I want to look at is entities. Yes. So basically, I mean, there's other parts to it. There is the software catalog, there's tech docs, and there's templates, and then it's got a couple extra integrations that go with it. But the one that we're sort of starting to look at is the software catalog. So you, as an enterprise team member, you want to be able to both see what you can use as part of the platform to avoid having to redo something that has already been developed, or you want to share your work with the rest of the team and document that and all that sort of thing. So the way that they do that is by creating these, what they call entities. So an entity within the Backstage ecosystem is either going to be, well, I'm trying to find a good example of one in here. I probably should have done this first. But it's like they have the top three are services, APIs, and components. And you can consume an API, you can build a component, and that can be shared amongst the team. You can build a service which exposes an API. And a lot of the language in there sort of starts to sound a lot like what we're trying to do with the component model, building components that can be reused, building interfaces that can be consumed by other pieces, applications that can consume those interfaces, or even parts of the application can consume those interfaces, and that sort of thing. So what we've put together is a bit of, this is our sort of my test space for Cosmonic in Backstage. And what I'll do is I'll show you. Actually, I'll use the cloud so I can get a visualization of the Wasm manifest that I've deployed. So what I've done here is I've got a Kubernetes cluster spun up with the wasmCloud operator. I've deployed this application using Wasm, and in here you'll actually see there's a special annotation. Zoom in here a little bit. There's an annotation here on that application, which is backstage.io/wasmCloud ID. And that's sort of like the standard way to tag something that will get consumed by Backstage. So by adding this in here and deploying that application, I've created an entity. In this instance, it's a service. And I've done that using the, where is just the catalog configuration. So this configuration can come from many different places, but in the example, I'm just using some config, and this is the Backstage side of the config. And what it will do is, this is where I'm tagging that. So I created this component. It's a service. It's got a name of Rust Hello World, and I've tagged it with that same wasmCloud ID, which is that Rust Hello World. And that's what links these two pieces together. So what we can do is then when I go into the wasmCloud, the Backstage dashboard, I can see that that's the service that it's created. And then when I go in here, we've got this extra piece here, which tells us a little bit more, and it actually collects this information from the lattice that I've got deployed, that the application is deployed. This is the current version that's deployed. It's got a version history. I've only got one version in there. But yeah, that's what it allows you to do, so that when someone wants to consume this service, say another team member, they can just go to this page and they can see the status, whether it's upline, whether it's online, or whatever they need to do. Now, there's a lot of different ways that we could take this plugin, but from a top level, this is the first piece that we wanted to build, is that status overview. So there's also this page, which is a similar piece, but what I'm planning to do is expand this with the parts of that application. So being able to see, like, what are the components that are inside that, what's the version of their interfaces, all that sort of stuff.
Lachlan, I have a quick naive Backstage question. It kind of seems like this could, is this dashboard like a Backstage thing, or do you lay out the CSS and stuff in here?
Yeah, good question. So all of these different, I would call them widgets. They're widgets on a dashboard. They're various pieces of Backstage. So this one is called, I think it's called the About card. The links one is sort of a way of defining what other pieces of a system are connected, whether or not this particular service has components within that. These three and this relationships one, that is all part of the standard Backstage offering. There's other ones in here, like it's got a CI/CD tab, which just doesn't have anything on it at the moment because I haven't integrated anything like Travis or GitHub Actions or anything like that. But there are plugins that exist for those things. This Kubernetes one is also a Kubernetes specific plugin, which if you'll noticed, one of the other things that I put onto this service definition was this label selector. I'm basically picking up here anything that has the wasmCloud operator. So anything that's managed by the wasmCloud operator should show up against this service. And that's why these things are showing up here. Apparently I've got a bit of a problem with one of my pods. Apparently, well, I mean, it's running. But yeah, you can go deep on stuff, and the integrations with Backstage are as much as you want to do. And that's where we have the questions, is we don't really know how people are going to build stuff with wasmCloud and then also share it amongst teams. So we're looking for feedback, but we wanted to get something out there so that people can actually start using it and at least throw a status overview on here. One of the best companies that's doing things with Backstage is Roadie. They have a lot of good high quality plugins. And yeah, there's a bunch of stuff that you can do with it, but yeah.
This is pretty cool. It kind of, yeah, yeah. Kind of seems like you could, this is a wasmCloud dashboard of sorts.
It could be. It could get that way. Definitely from an enterprise perspective, the typical expectation is when operating a Backstage instance is that's the main way that people will interact with the tools that are put in place around the services and stuff. So you would, if you want to know the status of your application, if it's deployed, then you might go to the CI/CD tab and see what the build status is. You might go to the Kubernetes tab and see, okay, all the pods running, or you might come to the wasmCloud tab and see, is everything actually running as part of the wasmCloud lattice?
Awesome.
Yeah.
All right,
So
before
as
I
I
ask
said,
all the questions. Oh, sorry, keep going.
I was just gonna throw a call out to the wasmCloud Slack. I don't think it is in there yet, but we're gonna throw up a Backstage channel in the wasmCloud Slack, so that if you've used Backstage before, or if you're interested in looking and helping out with the wasmCloud Backstage plugin, then we're all is. We want to hear it. We want to hear how you would want to use Backstage and wasmCloud and a plugin that unites the two. Anyone got any questions?
Right, nobody asked one, so I'll get one more. Does it support like hotel dashboards?
I believe so. Yeah, as far as I know, I think I saw one in there. Let me just whip up the Backstage. The Backstage
You can
website.
you can add your own plugins if you want
Mhm.
and extend the capability. It's extended through plugins, right?
It is. Yep. Yeah. So there's actually a plugin directory on the Backstage website. And let me just see what observability. There's a whole category for it. It doesn't look like there's too many in that category yet. But let's see, monitoring metrics. Yeah, there's a couple in there. None, no hotel, but there's a Grafana plugin. So you can surface Grafana dashboards in like a specific dashboard as opposed as a part of a service or an API or something. Um, New Relic, OpenCost, Prometheus, like there's a bunch of different monitoring stuff in there. I don't know about hotel specifically though, but like like Masood said, it's the plugin system is hugely flexible, and it wouldn't be impossible to add a Wasm, sorry, an hotel plugin that could show logs or do whatever. So yeah.
Cool.
All right. If no one's got any other questions, or I'm curious if anyone on the call has used Backstage.
I have.
That almost sounded sad about it.
No, the fact that basically you can put a lot of applications beside each other, I mean services,
Yeah.
and create a very kind of complex environment for self-service or very rich environment rather than complex. It's a very valuable thing.
Yeah.
Except that, people might not love the fact that you have to run it on Kubernetes.
So I mean, I guess it depends. You don't technically have to run Backstage or wasmCloud on Kubernetes. That's just the fastest way that I was able to get it spun up on my machine locally to have everything automatically do it. But you theoretically could throw Backstage on any VPS that supports Node because that's how they run their backend, and then also use the same connection. I just threw the Kubernetes piece in there because it's typically what microservices and that sort of thing are. They're kind of paired at the moment, but you could. There's nothing about our wasmCloud plugin that requires Kubernetes. I haven't quite got the repo sorted yet, but that should be up this afternoon. The plan is to update the last pieces of the versions that I need to change and then get that published. But I'll post that in the wasmCloud Slack and we'll get it put into the show notes here once that's ready.
Awesome. Yeah, thank you, Lachlan. I'm pretty excited about this, so I'm excited to poke around. I'm not feigning excitement. This is the first time that I saw it too. Like, so it's cool. Okay, then I think we can go ahead and move on, get the last 15 minutes or so of the call, and I've got a couple discussion items that I wanted to make sure that we had a little bit of time to talk about during the call. This might be kind of rapid fire because it's kind of quick and forward looking, but please, folks, feel free to raise your hand or ask questions kind of as we go along. You can see the wasmCloud community agenda, right? I didn't share the wrong thing. Yeah, it looks right. Okay. So the first thing I wanted to talk about are some upcoming changes to Wash build. And for those of you who have been around For a while, Wash Build started as a way to be able to build components in languages that wasmCloud kind of knew about. Like we started with Rust and TinyGo because we understood how to build components from, going from some Rust or TinyGo source code to building a WebAssembly module and then adapting that to a component. And Wash Build was really, really nice because we could bundle the WebAssembly adapter to go from WASI P1 to WASI P2 inside of Wash. We could also understand what tools that we needed to shell out to and embed tools like WIT BindGen so that you didn't need to have that CLI installed locally. Now, not every aspect of that is going to change, but one specific aspect of it that is going to be a whole lot neater and nicer over the coming weeks is the way that we build source code to a WebAssembly component. Now, this is a blog from earlier this year on the in the Rust toolchain, where essentially the target triplets that you use to compile code to a WebAssembly target are changing. So there was wasm32 unknown unknown, which is no WASI interfaces. There's wasm32 WASI, and that was kind of how it was until very recently. But we're actually changing, we as in Rust. Rust is changing this to be the target triplet wasm32 WASI P1, which is built for building WebAssembly modules, and the addition of wasm32 WASI P2, which actually compiles and does the adapting step directly to a WebAssembly component within the Rust standard toolchain. So this is not something that we need to do on the wasmCloud side anymore, which is super nice. This actually works today on Nightly. So if you download the Nightly toolchain for wasm32 WASI P2, you can compile our wasmCloud components directly by doing, cargo build target wasm32 WASI P2. And on the other end of that, you get your component that you can launch in wasmTime or wasmCloud or what have you. So as we move forward, we actually just shipped an update to the latest version of Wash that changes our compilation to go from wasm32 WASI to wasm32 WASI P1. So this will stop you from seeing warnings about this previous target being deprecated. But in the future, as soon as wasm32 WASI P2, gosh, so many of these, is off of the Nightly toolchain, like it's included in the standard toolchain, we're going to update Wash and the steps in Wash build for Rust components to just use this directly. So we're going to remove the adapting step on the Wash or the wasmCloud side and instead just use the native cargo compiler. And this is going to be really nice. It is actually going to make Wash build a whole lot less necessary for Rust components. It will be nice because we also include the step with Wash where we sign the component using generated in keys, which is required for secrets access in wasmCloud. But building it is going to be a whole lot simpler. Masood, I'll get to your question in just a second, because I'm just going to go through the other part of this one. But I did see your hand. In addition to Wash, TinyGo also ships support for WASI P2. Hey, there it is. It's the first one. TinyGo also ships support as a target for WASI P2. And with the latest innovations we've been doing with the component SDK Go, with Waj, just a general whole swath of upgrades and updates to our Go component experience, we are also here's the feature that that Lucas filed, which thank you, Lucas, for helping us stay accountable here. TinyGo components will also be built directly to the WASI P2 target instead of going to WASI P1 and then being adapted. Now, this is something, of course, that changes per language. Oh, here's the PR that Victor did to actually do this update to WASI P1 and Wash. This changes per language. If you use a tool chain like componentize Py or componentize JS, you're natively getting the component anyways. In languages like C, which Colin Murphy just submitted an example, you may still need to do the adapter step there as well. But for the languages that we look at and we are calling our kind of our first party languages, the ones that we distribute examples for with wasmCloud and Wash build, the support's getting a whole lot better. So you may not notice a lot happening different, but we're going to be updating our examples to use the native toolchains for TinyGo and Rust in order to build directly to a component rather than doing this adapting step on our own. Do folks have any other questions? Masood, I know you raised your hand. I just wanted to also just note the TinyGo one before we got too late.
So Brooks, from a user perspective, this becomes just default targets, and still we can choose other targets. I mean, I'm thinking about when P3 comes along and Rust hasn't caught up, right?
Yeah. Yeah, I think that what this will do basically is update the default for when you're running wash build. We have support to pick a wasm target in the wasmCloud.toml. You can specify P1 or P2. We are going to change the default to P2 because everything that we've been doing has been building a P1 module and then adapting to a component. And there's really no need to do that if the standard tool is going to take care of it. I'm not 100% sure if WasmP3 getting released means that there will be another target triple that gets updated in the compiler. But in that case, we would likely do the same thing. But since that hasn't happened yet, I don't think I have enough. I don't think I have enough evidence to say what we would really do there. But the default that we want for wash build is for that to always be building the latest version, the latest and greatest of a component, something that works out of the box with wasmCloud now. So even if wasmP3 drops and then it gets released in all the compiler tool chains, but wasmCloud didn't quite add support for it yet, it won't be added until that's like the nice end-to-end experience.
No, understood. I was kind of asking for clarification
Yeah.
about it's only the default that is changing and flexibility and option remains in case that we need to change the target.
Yes, yeah, completely. Thank you for that clarification. Let me show you, I can show you an example of this. So, showing the right thing, right? Yeah, so internally inside of Wash, when you build, we have this whole set. Well, this is a match statement, but this kind of set of wasm32 WASI P1, WASI preview 1 will go to WASI preview 1. And then moving forward, we are going to use this target for WASI P2 as the default. We also have support for our core module, but this configuration will remain. It's more just, like you said, doing the right thing by default. All right. I do have a little extra information that just to, like I mentioned, WASM32 WASI-P2, the target is still limited to Rust nightly. If you install it, you can use it, and it's great. As far as I know, it will be included in stable in the next minor release of Wash, which is 1.82, I believe. What do I have right now? Yeah, 1.82. So that is when we'll start making this move, changing our examples over, and then using that directly. Okay. If folks have any other questions, just raise your hand, but I'm going to keep on going since we only have a few more minutes. I wanted to bring up another feature that we've been working on, or that I've been working on the Wasm side that we've gotten a couple discussion items about, which is a shared component between two different Wasm applications. And there is a fairly large PR that's up now that implements most of what this should look like. But I wanted to show an example just to get some discussion going around what this actually means when we talk about shared components or shared providers. So right now, if you had two different applications, there are two different microservices that you manage and are running. You'll have to launch you have two different applications. You'll have to launch an HTTP server capability provider in both of them, even though you're only using it for the one component. And that's like really not the level that our HTTP server is designed to operate at. It's designed to be a multi-tenant HTTP server. Our providers are all designed to be multi-tenant to serve multiple components with different configurations. And this is really in line of chasing that goal. So let me show you an example of this is an example of a component, no, an application that we can use to better reshare or reuse capability providers and components at runtime with multiple different applications. So I have this shared HTTP. Oh no. Hold on, I just lost it because I zoomed in. Oh, there you are. I have this shared HTTP application, and what this does, it defines an HTTP client and an HTTP server. So these are two capability providers. I may choose to run this on a specific host, like in a cloud next to my load balancer, so that HTTP is being interpreted or intercepted as quickly as possible to get it into the wasmCloud system. Now, all I had to do in order to make this a shared manifest or a shared application is add this annotation. So I'm saying, hey, here's the special shared annotation for wasmCloud, and I'm going to set this to be true. And what that means is now I can write as many different applications as I want after I deployed that, so that I can launch my hello component, my hello world that maybe just takes an HTTP request, makes one of its own, very nice. I can link it as usual to a capability that's written in this manifest. But instead of specifying this capability or this capability provider with an image reference and a trait to say how it should be spread across different infrastructure. All you need to do here is you can refer with this application block to an already running component in a different application. So you need the name of the application that's running and the component in that application, which you can see two examples of here. So these are two capability providers, one that I need a link to, and the other one that I actually need to create a link from this one provider to the component running in this application. And we support both scenarios. So both of them, we support configuration, linking to and from a shared provider. But really the cool part of what this enables is now I can run an application locally, which is just my HTTP server. And then every single other application that I use every single different component that uses HTTP can just reuse that one HTTP server locally, potentially using the new feature like path-based routing so that each component gets its own path or different address, things like that. So the feature itself is actually going to be very simple when it releases. The hard part or what is making this take time is that there's a lot of validation and concerns that we want to make sure that we catch at the Wasm level. So if you have a shared application and you have an application that depends on that, if you try to undeploy or delete the shared application, you shouldn't be able to do that. I want to make sure that we can do validation on links to make sure nothing is being duplicated there as good as possible. So there's plenty of validation there, but I just wanted to note this as a feature that's coming up for you folks that are building platforms that are looking for a higher level of sharing of application components between different applications. I think that at the base, this probably won't show up in many of our examples, but I think it would be very useful to showcase an example where one component can talk to another across different applications, for example. So I wanted to just, we've colloquially talked about shared providers, shared components a couple of times now. I wanted to give a little background on what that feature actually means for Wasm. And since we just released Wasm sort of 15, so probably land in the next version of Wasm along with a couple examples on how to use it. So this should be pretty neat. I'm going for pretty strict validation. I don't want to try and reinvent everything here. It should just work for the basic use case of sharing between different manifests, and then we'll go from there. I can maybe take one question someone has there, but if not, I'll just go on to the next one. Sorry to all the Wasm maintainers who have to read all of my refactors and updated code. Okay. Well, this last agenda item is arguably the most important discussion that I had for today. And that is that wasmCloud Q4 is coming up. We are rapidly approaching the end of Q3 of this year, which is wild. It's been a very quick couple of months of wasmCloud development. We are going to be designing this community-led roadmap, or we're going to be finalizing what goes onto the roadmap, not this following week, so the next community meeting, but the one after that. So next community meeting, 2 weeks from now, will be when we do a road mapping session to grab issues, fixes, features, and prioritize them for the wasmCloud community. I've got a couple ideas, I think, to continue to improve the way that we do the road mapping session and continue the way that we are able to encourage folks from the community from contributing. Because what we did from Q2 to Q3, I have already been incredibly happy with how much work the community has taken on from the roadmap specifically, not just features and issues that pop up over the quarter. I mean, if you look here on the in progress, more than half of these are being taken on by wasmCloud maintainers, half of them are being taken on by wasmCloud contributors, and that is a ratio that I love to see. So to continue in the spirit of this community roadmap planning, and to give folks maybe a little bit more time to put in their feedback and thoughts, I created a discussion in the wasmCloud repo. So if you just go to the main repository and then hit discussions, I made one Q4 2024 roadmap. I might pin this. I'll figure out how to do that later. This I want to keep as a place where everybody can share their thoughts, share the things that they either liked from Q3 or wish that they could see the wasmCloud support by the end of the year. I want to be really clear that, if you're a longtime wasmCloud user, if you're just trying out for the first time or just kind of stumbling on this community call, everyone is welcome to comment on this. And I have a couple ideas of what I would love to see in wasmCloud over the next couple of months. And I'm planning on sharing them in this discussion thread as well, so that folks can put their thoughts out there and say that seems cool, but it doesn't seem more important than this thing. We should totally do this first too. So I want to keep road mapping as something that's really nice for everyone to see as a place to go and contribute to what is a priority for the wasmCloud project now. And I think that this should be really nice. I don't use GitHub discussions that much. This may or may not be a really nice place to talk about this. I would love to talk about this in Slack, and I think it's a lower barrier to entry for folks who just come across the GitHub and want to leave comments. So this is my ask for you all. If there's something that you've been thinking of taking on, you think that wasmCloud would be all the better for, features that you wish you could see, improvements that you've noticed that we haven't been able to prioritize, this is a great space to leave those comments to make sure that in 2 weeks when we go through the road mapping session, that's things that are always on this like top level dashboard for us to take a look at and complete. So I'm going to let that one sit in the air for a little bit. We are over time, so I think that this is a pretty good time to segue anyways. Do folks have any last second questions or comments on the wasmCloud roadmap session? All right. Thank you everyone for coming. Please make sure to put your feedback on the quarter four road mapping session. It is always better when we do our community road mapping sessions, when we have the opinions and thoughts from you all. So that is my huge ask for you. So I think that is all that we'll do today. For all of you watching on YouTube, make sure to like, comment, and subscribe or whatever. And everyone, I hope you have a wasmCloud day.